Okay, girls, let's continue with question number 4 now. Okay, question number 4. What is the mass of 0.25 moles? Mass we have to find. 0.25 moles are given for hydrated copper 2 sulfate. How we can find the mass? Yes.
Miss, I think it will be the moles multiplied by the MR.
Moles multiplied by the MR, that's right. Mass will be equal to moles multiplied by the MR. Moles are given to you, 0.25. What about MR?
MR is 160.
MR of this whole copper sulfate you need, because 0.25 are the moles of hydrated copper 2 sulfate, means this whole copper 2 sulfate with 5 water molecules. So what is going to be the MR?
It will be 160.
160?
Plus only 18.
No, plus 5 multiplied by 18.
5 times 18.
Multiplied by 18. I didn't see the 5.
Right.
I have
to check it
one
very
question.
carefully, because 5 water molecules are there in the formula. That is going to give you total MR. Yes, Luna.
Miss, I have one question. Miss, didn't we say that this point means multiplication, not addition?
This point means multiplication. Like this formula is multiplying with this. But for finding MR means total mass. Then we are adding all together. Copper separate, sulfur separate, oxygen, all we basically add. So copper sulfate total is 160. 5 waters are 5 times 18. Adding them together to get the total MR. Okay. So tell me the final value. It is going to be 250. Now apply the formula. 0.25 moles times 250. The answer is going to be
62.5, which is C.
right. 62.5, which is C. Okay. Then your question number 5, A and B is not from the same topic. We'll do them later. You can skip question number 5, A and B, and move directly to question number 5, C. Okay. Ammonium sulfate is used by gardeners as a fertilizer because it contains nitrogen. Why the chemical formula for ammonium sulfate is NH4 twice SO4? You can skip this part as well. Do the second part and third part that is related to this chapter. Okay, 5C, second and third part only. Calculate the relative formula mass of ammonium sulfate. Yes, means basically they are asking you MR value of ammonium sulfate.
So, Miss, I think that we will multiply the 2 by the N and multiply, which will be 2 N2, and multiply the H, the 4H with 2, so it will be H4.
8 hydrogens.
Yes.
So this,
I mean H8.
Right, Jana said right. This 2 basically is multiply with nitrogen and multiply with hydrogen as well. So means 2 times 1 means 2 nitrogens are there. 2 times 4 means 8 hydrogens are there. How many sulfurs are there?
1.
4
oxygen.
and 4 oxygen.
Right. So now put the masses value and find the total.
But Miss, we find from the periodic table, right?
Yes, from the periodic table always. So you can just go to the periodic table and check out nitrogen, hydrogen, oxygen, and sulfur. Okay. Nitrogen here, 14. Oxygen, tell me.
16.
Sulfur.
Yeah, 16.
The bigger number.
Sulfur is 32.
And hydrogen is?
1.
1. So 14, 16, 32, and 1. So now come back to the paper. 2 times nitrogen. 2 times 14. Plus hydrogen is?
Hydrogen is 8, which is 8 multiplied by 1.
Right. Sulfur?
1 multiplied by 32.
Oxygen?
Which is 4 multiplied by 16.
Right. Get the total.
Miss, the total is 132.
Very good, 132. Okay. Now, this will help you in next question as well because we need MR whenever we are doing some calculation. Okay. Calculate the mass in grams of nitrogen in 1 kg of ammonium sulfate. Okay. This question is a little different question from all the questions that are given to you. Okay. 1 kg of ammonium sulfate is given to you, right? And you need to find the mass of nitrogen in grams. So this one basically, there is no need of this 1 kg here. This is some extra information given to you. What they are basically saying, they are relating the nitrogen with
We'll
ammonium.
subtract nitrogen from the ammonium sulfate.
No, we need nitrogen only from ammonium sulfate. Yes. How we can do? Any idea? This 1 kg we will use, but not now. We will take the ratio. So basically, ammonium sulfate
think
mass is
this-
how much?
Yeah, we need to find the mass of the ammonium sulfate, which will be the
Mhm.
MR multiplied by the moles.
Okay.
Then after that, we can find, because we have the mass of the total ammonium sulfate, then it will be easy to find the nitrogen.
Okay. Not this way. Let me tell you how we can find. So basically, what we need, we have ammonium sulfate and we want how many grams of nitrogen are there in this ammonium sulfate. Okay. So we can first of all write their MR or AR values. MR of ammonium sulfate is 132, right? Here we need the nitrogen, not AR, not MR. We need how many nitrogens are in this formula. And what is the total MR of nitrogen in this formula? So in this formula, how many nitrogens are there?
2.
2. That is 2
yeah.
times 14,
Yeah.
right?
Yeah.
So it means that is 28 grams. So when we have 132 grams of ammonium sulfate, 28 gram is nitrogen inside. This point is clear? Okay. 132 grams of ammonium sulfate has 28 grams of nitrogen in the formula.
Wait,
Okay.
but how isn't 132 is the
Total ammonium sulfate,
yeah,
MR.
mass.
MR. It's basically 132 MR.
Yes.
So that is also basically grams per mole. MR is the mass, molecular mass. So if molecular mass of ammonium sulfate is 132, out of this 132, nitrogen is 28. Clear? Now we need, if ammonium sulfate is 1 kg, how much is nitrogen? That is your question. If ammonium sulfate is 1 kg means how many grams?
1,000 grams, right? 1,000 grams.
1000 grams, right. So they are asking if ammonium sulfate is 1000 grams, how many grams of nitrogen are there in that case? You may have used this in your maths as well. You can simply cross multiply.
Cross multiply.
Very good.
Cross
1000 with 28 and nitrogen we have to find, let's say X value or whatever that we need. So your mass of nitrogen will be equal to 1000 multiplied by 28, right? Divided by 132. Solve it. Tell me the answer.
Miss, it's 200, 1, 2, 1, 2, 1, 2, 1, 2. It's a repeating number, so we can say 212.12.212.
Right. 212, 212.1. You can write 3 or 4 digits total. 212 grams. Okay. I hope this question is clear. Otherwise, I can repeat it. So basically, sometime they can ask you from the main formula, how much is one specific element? Okay. So right now they're asking how much is nitrogen in main formula. No need to find moles or anything. We are just relating the nitrogen with the main formula. The main formula has the MR value 132. In this 132, nitrogen AR or MR is 28 only. Its mass is 28 only. If main formula has somehow 1000 grams, what should be the mass of nitrogen then? So we are going to just cross multiply and get the mass of nitrogen. Okay, this is clear to everyone?
Yes, Miss.
Okay.
Yes, Miss.
You can finish writing, then we can move forward. After that, we are moving to question number 6. Okay, I want you to solve it. It's easy. When zinc oxide reacts with dilute nitric acid, zinc nitrate is produced. Equation is given, balanced equation is given to you. 0.200 moles of nitric acid reacts with excess zinc oxide. No information about zinc oxide, but we know the moles of nitric acid, which is HNO3 here. Okay. A mass of 15.3 grams of zinc nitrate is produced. Zinc nitrate mass is given to you. Calculate the percentage yield of zinc nitrate. Okay. Now, what is the formula of percentage yield? Percentage yield is equal to yes, girls. Anyone remember the formula? Percentage yield equal to
the actual value and the prediction value multiplied by
right.
one.
Actual
one.
yield over theoretical yield. Or you can say predicted one. Or theoretical. Multiply by 100%. Okay. Now tell me, they said if we do this reaction, 15.3 gram of zinc nitrate is actually produced. What is this value? Is it actual yield or theoretical yield?
Actual.
It is actual given to you. That we basically got by the experiment. Theoretical is going to be more than this or less than this? Predicted one is more than this or less than this?
More.
It should be more, right? So we
More.
need to find this theoretical or predicted
We'll
one.
use the moles.
Right. We will use the moles to get the mass of this theoretical one, and then we are going to use this formula. Okay. So
Apply
now,
0.2 and 189 to find the mass. And
okay,
then
now we basically, yes, what you said again.
we'll multiply the moles 0.200 by 189 to find the mass. And
Right.
then we'll put as the theoretical yield.
Right.
And then we just apply it in the formula.
Right. So see, for this nitric acid moles are given to you. You can relate this molar ratio over here. This is 2:1, right? So if these has the moles, this one has the mole 0.200, what should be the moles of zinc nitrate?
Divide by 1?
Divide by 1. 2:1 means
Divide
over
by
here it is 1, half. So 0.200 divided by 1 is 0.100 moles.
0.100, yeah.
Okay, so we got the moles here, 0.100 moles. Now using these moles, we can easily find the mass. Tell me the formula that we can use here.
Moles times the molecular mass.
Right. Moles times the molecular mass, or MR. Moles you have 0.100, which we got from the molar ratio. MR of zinc nitrate is given to you. No need to find it separately. 189. Get the answer.
18.9.
18.9 grams mass. So this is basically now which yield, actual or theoretical?
Theoretical.
Theoretical one.
Theoretical, which one's more than the
Very
actual.
good. It should always be more than the actual one. That is the trick as well, to see that you're getting the right answer or no. Now apply this actual one back in the formula, theoretical one in the formula, multiply by 100. So it will be
15.3 over 18.9 times 100.
very good. Find the final answer.
80.95.
80.95, that is very close to 81%.
81, Miss.
So it is somehow a good reaction giving us 81% product. Okay, I hope this is clear to everyone.
Yes, Miss.
Yes, Miss.
Let's move to the next question. Question number 7, A and B is from organic chemistry. Skip for now and move to the question number 7C. Okay, this one you can quickly do. Quickly, within a second, tell me the answer. Another organic compound has the percentage composition by mass. Carbon, hydrogen, oxygen, percentage is given. You need to find empirical formula. I'm not going to tell any step. You will tell me all the steps. What will be the step number 1?
Then we write, firstly we write the table.
Right,
C
First, you have to write the
O. The mass is of carbon is 38.7.
right,
Mass of hydrogen is 9.7.
right.
Mass of oxygen
No.
is 51.6.
Then,
Miss, and then we find the like you can say the AR,
right, AR is
which
going to be,
is from the periodic table.
hmm,
For hydrogen and oxygen, hydrogen is 1 and oxygen is 16. For carbon, it's I guess 6. We can say yes. No.
No, carbon is 12.
Uh,
Start
oh,
remembering
12. Yeah.
them, okay? Carbon
Yeah.
12, hydrogen 1, oxygen 16. Now, next step.
Now we find their you can say their moles. Moles.
So mole of
We
carbon
divide
is going to be,
mass over molecular mass.
get the answer, tell me the answer.
Miss, the first one will be 3.225 for carbon.
3.225 for
The second one
hydrogen.
for it will be the same.
Yeah, it's same
For
because divided by 1 is 9.7. Okay. For oxygen,
it will be also 3.225.
then next step. To get the
Divide
molecular
by
ratio.
3.225.
And then divide them by the smallest.
Smallest one.
number.
Very good. Divide with the smallest one. 3.225 all. So this will give you 1 ratio.
1, 3. Between them is the answer will be 3.0075.
So 3.
So
Small
should
number
we
is 3.
3, right, Miss?
So what will be the empirical formula then? 1, 3, 1 is the ratio.
So C already C H 3
H3O.
and then O.
Very good. Okay,
Yes.
you got the empirical formula. I told you already how to find N and how to find the molecular formula. Now, molecular formula mass is given to you 62. Empirical formula mass you can get from here easily. You have to find the molecular formula. What was the number N? N was equal to
N equals to molecular formula over empirical.
formula over empirical formula.
very good. Molecular formula mass over empirical formula mass. Molecular formula mass is given to you already 62, but we need empirical formula. Sorry, molecular is given to you divided by empirical. 62 divided by empirical. Empirical is 1 carbon, 3 hydrogen, 1 oxygen. So how much is the mass?
6
12.
12
31.
Carbon 12, not 6,
12
Luna.
plus
Remember it.
3 plus
Mhm.
16.
For
12,
3 hydrogens, 3 plus 16. Total will be
31.
31.
31.
Yeah. So it will be
Right here.
62 over 31.
That will be
Which
total
2.
2. Very good. So
Then
molecular formula is going to be then
C2H6 O2.
Very good. It is multiply this 2 number with empirical formula.
Oh yeah, this one is for, it's like the ratio. So like we just
Ratio, yes. We are going to
Okay.
multiply this number back with the empirical formula to get the
so
actual formula.
6 to H 6 no yeah C2 H6 and then O2.
Very good. So C2H6O2 is going to be the molecular formula over here. Okay.
Yes.
So by chance we are getting 2 over here again and again, but it can be 2, 3, 6, any number possible. Whatever number you are getting, multiply back with the empirical formula. Okay. I hope this is clear and easy till here.
Yes.
Okay. Then question number 8, we are skipping, not from the same chapter. We will do it later. We can move to question number 9. Again, empirical. Just do it quickly on your notebook and show me the answer. Tell me the answer. I will give you 1 minute, solve it, and then we'll solve it here. You have Helen 1301 is a compound used for fire extinguishers. This compound has some percentages by mass. For carbon 8.05, bromine 53.69, fluorine 38.26%. Their AR value of carbon is 12, bromine is 80, fluorine is 19. Find the empirical formula on it. Quickly just solve it and tell me the answer.
Yes, what is the 1301?
It's the name of a compound. Helen 1301. Just a name of the compound. So we don't
the
1301.
name. Okay.
It's
So
a
Miss,
compound which is used in fire extinguisher. So we are not concerned with 1301. Ignore it. Just use these percentages and these AR values to get the empirical formula of this compound.
so Miss C is 8.05. So I don't confuse, between the masses.
Yes. 8.05 is carbon. 53.69 is bromine. 38.26 is fluorine.
Oh, okay. Thank you.
Okay, let me see who is giving me the final answer quickly. A, B,
Miss?
C, D. Okay. Which formula is the right empirical formula?
Miss,
Hmm.
the battery of my laptop is almost gonna finish. Can I leave and put it in the charger and come back?
Yes, sure. Yes, Fatima.
Yes, I
Okay,
solved
thank
it
you,
and I got an answer B.
B. Jude got the answer B. Okay, let's see what other students are getting. Yes, girl. Anyone else is done?
Still
Miss,
answer.
wait, hold on. I'm almost done.
Okay, take 1 more minute.
Yes, Miss, it's B.
Shaima also got B. Okay.
Yes, Miss. I also got B.
Mariam got B. So it means it is B.
Miss, it's B. I also got
Right.
B.
Okay, so let's just
B is
quickly
1,
solve it.
BR is 1, F is 3.
Right. So we have these as the masses, right? 8.05, these percentages are the masses. We have to just divide these masses with their MR values or AR values, right? So mass is given to you, for example, for carbon 8.05, so divided by 12 here. For bromine divided by 80. For fluorine divided by 19 to get the moles.
Miss, by chance, chlorine, carbon got
Yes.
0.67 and bromine got 0.67 by chance. I was
Right.
shocked. Yeah.
Yes.
Okay, so it can be
And
same,
the
no
last
problem.
is
And fluorine?
2.01. 2.01.
Okay. Then the next step is?
We divide them by the smallest. So 1, 1,
Right.
and then
So
last one.
all divide with 0.67. So 1, 1, and
3.
3. it means 1 carbon, 1 bromine, 3 fluorines are there, and that is the B formula. Okay, very good. Well done, girls. Let's move to the question number 10. That is from today's topic, molar volume. A little different question, but I hope you can solve it. What is the maximum volume in dm cube? We have to find volume in dm cube at RTP. Means we can use the formula of RTP here. Obtained from 17.6 tons of molten potassium chloride. 1 ton is equal to 10 raised to power 6 grams. So this is basically mass given, but not in grams. It is in tons. We can easily convert in grams. Conversion is also given for your convenience. MR of KCl is 74.5. Molar volume is also given. That molar volume for RTP is 24 dm cube for 1 mole. Okay. So what we can do here?
Mole equal.
First, we convert the tons to grams.
Okay.
Yes.
That will be
17.6 times 10 power 6.
right. Just multiply with 10 raised to power 6 so grams. Okay, we got the mass. We need
It will be
volume.
Yes, it will be the
It
Hmm.
is moles times
multiply
24 into
molar volume.
Very good. So basically we have the volume is equal to moles multiplied by 24 formula. Okay. So we can do volume is equal to moles multiplied by 24 dm cube. But where are the moles? We don't know.
We have to
don't know
find
about the
it by the
moles.
grams and the molecular mass.
Right. So first we need to find the moles, which is mass in grams.
divided by molecular mass. Yeah, in grams, multiplied by molecular mass.
Divided by, you said right before. So mass is,
Which is provided to us already, so we just divide them.
right. So MR is given to you 74.5. Okay, tell me the moles. How many you got? Yes, girls. 17.6 tens per 6 over 74.5. How much?
Miss, I got a long number. 4, 2, 2, 4, 0, 0, 0, 0.
Okay, so you will just convert it into 10 raised to power 6 notation, 10 raised to powers notation, basically, a standard notation. So 2.36, 10 raised to power 5,
So
basically.
422.4 multiplied by 10 to the power of 6.
Yes, like this you can
Miss,
write.
what if I only rounded it?
You cannot round it too much because then you may not get the right answer.
Well, the number, it's only 4 digits after the decimal. So I can round it.
Then you can round off. Yes, then you can round off. Okay. So these moles you got, multiply them with 24.
Miss, it will be 5664000.
Okay. Multiply by 24. So what is the right answer here?
5664000.
And that is your answer.
Which
No,
is
wait. We missed one thing. They're not asking the volume of potassium chloride. Mass of potassium chloride is given to you and moles of KCl, potassium chloride, we calculated. But they are asking volume of chlorine.
Huh?
They are not asking the volume of KCl. They are asking the volume of chlorine here.
How
Okay.
did we get the answer
So I will
correct?
provide you a balanced equation here because in the exam you need to write the equations, but you can do only when you will be done with the chapter of writing equation. So let me give you the equation here. So equation is 2 KCl is giving you 2K plus Cl2. So we got the moles of potassium chloride KCl. We did not get the moles of chlorine here. Getting the point? So moles of KCl we got. We need the moles of chlorine. Then we need to find the volume of chlorine here. Okay. So KCl moles are
Find
given.
the ratio.
Ratio 2 ratio
2
chlorine.
yeah, 1
So
chlorine.
KCl moles will not be same as chlorine moles. It will be multiply 2 or divide by 2.
Divide.
Divide, it will be half because 2
Divide.
ratio 1 it is. So we need chlorine moles over here, and that is divided by 2. 2.36 10 raised to power 5.
Means divide by 1, not by 2.
No. 2 ratio 1 means KCl is double, the other side is half of it. Divided by 1 means nothing.
Just wait.
Multiply by 24. Now solve it and get the final answer.
Means in question number 6, we divided by 1.
Divided by 1.
Yes.
I will check again. No, divided by 1 means nothing.
Miss, the answer will be
Hmm.
2 you can say 2,802,000. We should do it power of the 6, right? 1.
So move the decimal. So it will go 6 times back. So it will become 2.83 10 power 6, right?
It's C. It is
C.
C.
C will be the right answer here. Okay, Jana, why we are dividing with 2, I will explain again. See, this is something 2 times KCl, 1 time chlorine. If we want to go from Cl, chlorine to KCl, then it will be multiply, double, multiply
Yeah.
by 2. If we want to go back to the chlorine, then it will be divided by 2.
Yes. Okay, I understood this part, but can you go back, sorry, for question
I will go
number
to
10?
question number 6. Sure. Yeah, this one.
Yes. Here it was 0.200. We
So
divide by 1.
then we divide it by 2 to get 0.1. 0.2 was the
yes,
original. Divided by 2, we got 0.1. It was
I wrote
divided by 2
1.
here.
I wrote
Okay,
1
it's
by. That's my
write 2 here. It's divided by 2 to go over there. Okay, 2 ratio 1 it is. Okay, let's go back to question number 10. I hope everyone is clear in question number 10. Anything to ask here?
Yeah, Miss.
Okay. Sometime if this equation will not be given to you for now, for your quiz number 2, I will give the equation. But in the exam, they will ask you to write the equation as well. Get the ratio as well. Then solve it. Okay?
Yes.
Okay, let's move to question number 11. Yeah, 11 is included. Okay. Try to solve it. Calculate the concentration in moles per dm cube for a solution whose mass is 6.9 gram, that is potassium carbonate, mass of solute, dissolves in 200 cm cube of water, which is solution, and MR of K2CO3 138 is given to you. We need concentration in mole per dm cube. What is the formula if we want concentration in mole per dm cube?
The mass of a volume.
Miss, number
Mass of solute.
mole.
Mass of solute over mass
Volume of
dm cube.
Number of moles of solute divided by the volume of solution.
Right.
Mole divided
of
by
solute divided by volume in what
volume
unit?
of solution.
Volume of solution in?
dm cube.
Very
DM.
good. Do we have the moles of solute here?
No, miss, we will find it. So the MR is given. We'll just divide the mass 6.9 by the MR, which is 138.
138 to get the moles, and that is 6.9 over 138.
0.0005.
0.05, not 00. 0.05.
0.05 moles. Okay.
Yes.
Now we got the moles and we have the volume, but in cm cube. How we can
Miss,
change it?
right,
We'll divide by 1000.
so it will be
200.
0.2.
0.2.
0.2 dm cube. Okay. So you got the volume, you got the moles, put it back in the main formula. Moles of solute over volume of solution in dm cube.
0.20. 0.25.
0.25, and that is your answer. C. 0.25
Yes.
mole per dm cube concentration we are getting. Okay.
Yes.